Good morning students, welcome back. Today we are going to learn one very important session in C++, that is static variables, constants and type conversion. See, in programming, most of the time we are using variables normally, but sometimes we need a variable to remember its value even after the function is completed. That is where static variable comes. Next, we will learn constants. Constant means value should not change, like maximum marks, EA value, number of days in a week. These values are fixed, so we must keep them as constant to avoid mistakes. Then we will go to type conversions. In C++, we use int, float, char, double, all types. Sometimes when we do calculation, the compiler automatically converts one type into another. That is called implicit conversion. And sometimes we manually convert, that is called the explicit conversion or typecasting. Finally, we will solve some small programs and debug errors so that you can clearly understand. So let us start step by step. Now let us understand static variables. Normally, when you create a variable inside a function, it is called a local variable. That variable is created when function starts and it is destroyed when function ends. So next time when you call the function again, it starts fresh. But static variable is different. Static variable is also declared inside a function, but it has a special property. That is, it will be created only one time and it will retain its value between multiple function calls. So even after function ends, static variable will not lose its value. It will stay in memory. Where we use this example, counting function call, tracking number of user login, maintaining a counter like number of times a button is clicked. Remember, static variable keeps previous value initialized only once. Lifetime is full program execution. Scope is inside the function, but memory stays. Now see this example carefully. We have a function called count. Inside the function we declared a static int c equal to 0. This c is initialized only once. First time when function is called, c becomes 0. Then we do c++ and print c. In main function we are calling c out 3 times. First call c equal to 0, then increments, then c becomes 1, then it prints 1. Second call c remembers previous value 1, then increments, then it prints 2. Third call c equal to 2, then it increments, then it prints 3. So the output will be 1, 2, 3. If it was a normal int variable, every time it would become 0 and output would be 1, 1, 1. So static variable is like keeping a record book. So every time you come, it continues from where it stopped. Now we move to constants in C++. Constant means fixed value. Once we assign it, we cannot change it later. In C++, we use keyword const. Example, const int max underscore students equal to 60. Const float PA equal to 3.14. We display them using cout. Important point, if you try to change the constant like max underscore students equal to 50, it will give error because constant cannot be modified. Why constants are important? In real applications, we do not want someone to accidentally change important values. Example, maximum seats, maximum marks, tax percentage, PE value. So by using const, you can make a program safe and readable. Now let us see different types of constants. We have integer constants like 100, 60, floating point constants like 3.14, character constants like a, string literals like SRM University. The example, max underscore marks equal to 100 is integer constant. PA equal to 3.14 is float constant. Grade equal to A is character constant. college equal to SRM University is string literal. We print them one by one. This is usual because constants help standardization. Instead of writing 100 times again and again, keep one constant. If requirement changes, change it at one place only. So constant improve readability, easy maintenance, fewer mistakes, better security. Use meaningful constant names in capital letters. Now let us understand the benefits of using constants. First benefit, no accidental modification. If it is constant, nobody can change it. Second, readability. When I see max underscore marks, I understand immediately. If you write directly 100, I may not know meaning. Third, easier maintenance. If maximum marks change, modify only one line. Then better debugging. Fixed values reduce confusion. Then compiler optimization. Compiler can optimize constants better. So in professional coding, constants are always recommended. If you have multiple constants, group them properly. Use constant. From today onwards, whenever values should not change, use constants. Now we come to type conversion. In C++, we work with the different data types like int, float, double, char. In real program, we mix them. Int plus float, float plus double, int plus char. C++ will convert one type into another type to perform operations. This is type conversion. There are two types: implicit type conversion, which is automatic by compiler; explicit type conversion, forced by programmer using casting. Type conversion is important because sometimes it causes data loss. Example, float 5.7 converted to int becomes 5. So we must understand when conversion happens and how to control it. Now let us see implicit type conversion. Implicit means automatic. Compiler converts without our instruction. Example, in a equal to 10, float equal to float b equal to a. Here, int is converted to float automatically. The program, a is int equal to 10, b is float equal to 5.5, c is char equal to a. When we do result 1 equal to a plus b, in a is converted to float, then added, so result 1 equal to 15.5. When we do result equal to a plus c, char is converted into int using ASCII converter. So result equal to 10 plus 65 equal to 75. Implicit conversion is easy but sometimes dangerous due to data loss. So be careful explicitly float to int. Now we go to explicit type conversion. Explicit means programmer forces conversion. Syntax: within bracket data type variable followed by variable name. Example, float x equal to 5.7. Then we have another variable int y equal to within bracket int followed by x semicolon. Now y becomes 5. In program, float marks equal to 85.75. Total equal to int of marks. So total becomes 85. Why explicit conversion? Because sometimes you want full control. For example, division of int by int gives int result. But if you want a decimal answer, we convert one operand into float. So remember, implicit equal to compiler does. Explicit, programmer does using casting. Now we discuss common issues in type conversion. First issue, data loss. Float 9.99 becomes int 9. Second issue, integer division problem. Int by int gives int. Example, 7 by 2 gives 3, not 3.5. Third issue, overflow. Large value stored in small data type. Fourth issue, unexpected ASCII conversion. Example, A becomes 65 in calculation. So, whenever output is wrong, check data type first. Type conversion is small concept, but creating big mistakes in exams and coding. So practice one. Now please practice these questions to improve your logic. These are some activity, find the bug. So in the float result equal to a by b, the result becomes integer value. So it should be converted into float. One variable should be converted into float. Thank you.